Hey everybody, this is Alex Merced from alexmercedcoder.com. It's been a while since I made a video. The last couple weeks I've been working on devnursery.com. If you haven't head over to devnursery.com, there's a lot of really cool resources available for you. The main thing is you can kind of see all the different playlists of videos that I've made, so that way you can find, if you want to learn Go, you want to learn Elixir, you want to learn Python, you can quickly find the videos you need. But also there is, like, you can sign up and get a user account and keep track of your to-dos and make blogs and have a public blog page. You can do that if you want. That's there, and I'm going to be adding more stuff as I go. It's been a fun project because what I've been doing is that each section of the website is actually built in a different stack. So there's actually parts of the website that have a Go backend, a serverless backend, that have a Ruby backend, and you can see at the bottom of the page, in the footer of each page, I describe what that part of the website was created in. So even though it's just one site that I could have probably done a lot quicker just using one stack, it's been a learning experience for me to learn lots of stacks. Cool, so go check that out, devnursery.com. But what we're talking about today is always a fun topic that's always tricky for people when you're learning JavaScript, especially if you come from a different language that does things in a more sort of traditional object-oriented way, in the sense that there's classes. While there's classes in JavaScript, they're not really classes in the same way that they're classes in C++ or Go. In a typical object-oriented language, the way a class works is you're creating a blueprint for what an object should look like. And basically every object is essentially built to the specification of the class, but each object is its own encapsulated object. So it's recreating those instances of the methods, the functions built into the class, the properties. They're completely separate, unrelated objects. In JavaScript, it uses prototype or prototypical inheritance as its way of kind of achieving the same thing, but it's different. So essentially what's happening here is that everything is an object. So technically arrays are objects in JavaScript. Everything is an object, and everything is inheriting from its prototype. What does that mean? All a prototype is, it's another object you look to for properties and methods. Okay, so any property your prototype has, you have. So let's create an object. Let's just kind of to show how this kind of works. So let's say I create a object. We'll call it const, and we'll use let just in case. Let object. We'll say mom. Okay. We'll say let mom equal an object, and she's gonna have black hair. Okay, and height, we'll say mom is tall. Okay, so there's an object and it has these properties. Now I'm going to set a new object, so we're going to call let child equal an empty object for the moment. And then I'm going to say child, or so let me refactor this just a little bit, just to make this a little bit clearer. So we're going to create a new object. So what we can do is we can just call the object keyword. So we're going to say, hey, it equals what this returns, which means it's going to create a new object. And then we're going to use the method set prototype of. So that means the resulting object that is returned is going to have this prototype. Okay. And the way it works is that the first object is the object we're setting the prototype of, so that's going to be child. Okay. Although we can't assign it to itself, so we're going to say an empty object. So just a new empty object, and the prototype of this new empty object is mom. Okay, so child is going to equal a new object that has the prototype of mom. Now, I never actually specified any kind of properties that the child has. Okay, so let's say I did want to say like the child dot favorite toy equals Power Rangers. Okay. Now we're going to do a few things. We're going to console log mom to show what mom has. We're going to console log child to show you what properties the child has. And the idea behind the prototype is that if for some reason the object doesn't have a particular property, it's going to go then take a look at the prototype. So it doesn't have the property, a copy of the property itself, but you can refer, it'll delegate, hey, go check out mom for this property. So if I were to say console log child dot hair, the expected behavior is that it'll be like, okay, child doesn't have a hair property, so I'm going to take a look at its prototype, which is mom. So I'm going to go check out mom. So let's run this code. There probably will be some fixes we'll need to make, but let's do it. Okay, let's load up the terminal. Node practice .js. Okay. Yep. There's some errors I see here. What am I looking at? Throw error. Cannot find module. Coding prac. Oh. I need to go one folder down. CD TypeScript. There we go. Now let's run the practice. Black is not defined. Oh, yeah, that's right. These are supposed to be strings. There we go. Okie dokie. Okay, so let's break this down. So first, when we console log mom, we see the two properties that mom has: black and tall. When we console log child, we only see one property: favorite toy. Yet, when I console log the child's hair, a property we do not see in the object, we still get back black. Because what's happening? Since the property is not on the child, it's going to go take a look at the prototype. Cool. So this allows you to create sort of chains of inheritance. Now if I were to console log mom's favorite toy, it's going to throw me an error because it doesn't work the other way around, because child is not the prototype of mom. So if I were to say mom dot favorite toy, it's going to just come back as like null or undefined. Yep, undefined. Because it would go look at its prototype and none of its prototype, and again, it would look at the prototype of the prototype. So for example, if I were to do this, let's let grandchild equal object dot set prototype of a new empty object, and this time it's going to be the child is going to be the prototype because it's the grandchild, so it's the child of the child. Okay, so that'll be that, and then let's do this. Let's console.log grandchild.hair, because what's going to happen, it's going to go look at the child prototype and see, hey, the only property here is favorite toy, but wait, child has a prototype, mom, and mom has black hair. Okay, so it should still console log the color black. Okay, so let's run that and confirm that, and that's what it did. Okay, so it goes up the prototype chain. Okay, so essentially when you're creating classes, in a sense, in JavaScript, what you're really doing is you're defining an object, and then when you're basically you're defining an object and a constructor function. And that constructor function is really what it's doing. It's taking a new blank object and making your new object setting that class object as a prototype of that object. And this is why this keyword is weird in JavaScript, because of this whole prototype thing. Because the this refers to, like, if I were to create a function, let's say if I were to do this. Okay, console log who am I? We're going to create a property called who am I, which will be a function. Who am I? Which is a function. Takes no parameters. It just console logs this. Okay, so whatever this is going to get console log. I'm only defining it once here on mother. No, I don't want that there. Save. Okay. But again, prototypical inheritance, all three should have access to this prototype. So I should be able to do mom dot who am I, child who am I, grandchild dot who am I. Okay, and that's going to console log this, but what this is going to change based on who runs the function. So even though the property is owned by mom, it's not necessarily, it should be console logging the actual invoker of the function. Okay, so let's give that a shot. Let me actually save it. Oh, cars in Brooklyn. Okay, let's see here. No practice. Okay, this. Okay, saying this is an object. How can I make this clear? Let's do this dot favorite toy. Okay, undefined. Let me think through this code here. Okay, so here was the main thing that needed to be different. It depends on how you define your function. If you define it as an arrow function, as I did a moment ago, the this keyword doesn't work the way it traditionally does. It doesn't follow the prototypical inheritance, I guess. Which is why arrow functions are so useful in your classes, because then you don't have to worry about binding this and what this means, especially for like click events. I know when I worked with AngularJS, arrow functions made it where you didn't have to worry about having to assign this to a variable so that with the instance of the class was clear. But if you use a normal ES5 function where you define a function like this, then this refers to whichever object invoked the function. And this is, if you ever used React, this is why you'd have in class methods, you would always have to do like bind this, like this dot bind this, because what would happen is that when the click event was really being invoked by the element, so it's being invoked by the button or the form the click event is on, or any event is on. So then this would refer to the element on your HTML page, not the class that defined the method, because of that whole prototypical inheritance thing. Okay, so watch what happens here. So what I did is I changed the function to say, hey, this create a new property, this dot last name equals Smith. Okay, so that means it should assign it to whichever object that that's invoking this. Okay, so we call that function who am I on all three objects, and then we're going to actually console log all three objects so you can see what the results are. So we do that, and at the very end we see mom now has a last name Smith. Okay, because when she invoked it, mom was this. So here we don't have that. Here all three of them have the last name Smith, because each one individually assigned that property to that individual object. And what happens is that when the property when the object has the property, it doesn't look any further. So basically, if I were to call, grandchild dot last name, it sees that it already has a last name and would not go further to look up the prototype chain. It wouldn't go then look at child, and then if it doesn't find it, it looks at mom, since it already has a last name. So that's always the thing you want to think about. So like, if the object itself doesn't have the property, it's going to look at its prototype. And if its prototype doesn't have it, it's going to look at that object's prototype and just keep going up until there's no more prototypes to check out. And once you kind of appreciate that and what's kind of going under the hood in JavaScript, because this is fairly different than the way a lot of other languages handle objects. Although I can see the benefits of this, because that way you're not having multiple copies of the same method, because it's all referring to that one into the same method. So I imagine there's some memory benefits to this, which are good, and particularly useful in I'm sure it was, far as my understanding is that when the creator of JavaScript first created JavaScript, he was modeling it off of Scala. Okay, Scala, which is a functional programming language, which is why JavaScript lends so well to functional programming. And then they kind of sprinkled in some syntactic sugar to make it more like Java and call it JavaScript, because Java was so big at the time. And then Java was really like C++, syntactically similar to C++, because C++ was so big, they wanted to make sure that it leaped from one language to the next. And this is why C#, syntactically similar to Java, because for the same logic, they want to make sure that it's easy to adopt for the existing set of programmers. Because when you have like a drastically different syntax, it just makes it harder for existing developers to make the switch. I mean, imagine like switching to a Lisp-based language like Clojure, where the syntax is very, very different. And if you're not familiar with it, go watch my videos on Clojure. It's very different. Clojure or Elixir is all in that sort of family of functional languages. So, cool. I think that hopefully gives you a better idea of what prototypes are and how they work. And that'll hopefully also help you appreciate what's going on under the hood when you're creating classes in JavaScript, and make you realize at the end of the day, it's all an object. So whether you construct your objects using like a factory style, where you create a function to create your objects, and assemble them within the function instead of creating a class, or you create a class, at the end of the day, you're just creating more objects. Okay, you're just creating everything in JavaScript as an object. Your arrays are objects, your functions are objects, and you can actually, set a function as a prototype. There's all sorts of weird stuff you can do in JavaScript, which makes it pretty cool. But this, I think, gives you a flavor, an understanding of what all that means. So hopefully you guys enjoyed this. Leave some comments, subscribe to the channel, check out devnursery.com. Thank you guys very much. Have a great day and enjoy.